Hi, and welcome to the second episode of the series, The Dark Side of Git. This is Paul, and today we are going to start talking about history manipulation. When we say history manipulation, what we mean is the act of changing the history of commits. In Git, there is a surprising number of ways one can do that, some of which can even lead to eventually unrecoverable pieces of data. Don't worry though, doing something so destructive is incredibly hard in Git. It will protect you from the worst of these actions. The first action we are going to see is resetting, or the Git Reset command. Resetting is one of the ways we can go back in time and possibly undo more recent changes. For example, we can go back to a previous version which didn't break production. Let's say on our local repository we have one commit that is not present on the remote branch we are tracking. Essentially, this change has not yet been pushed. This is a very good situation, as we are going to see. Do you remember our hashes, the ones we saw to the left of the commits in our graph? We've replaced them for this slide with a slightly different notation. This notation we can use when referencing commits to make it a bit easier. This method makes use of head and the commit it points to find out which commit we mean. Tilde followed by a number n signifies the nth parent or ancestor of the commit head points to. In the case of commits with two parents, merge commits, we can choose the parent by using a caret symbol, potentially combining it with the tilde symbol. But bear in mind you can still use the hash to reference a certain commit and avoid confusion. In our following example, we are going to reference a commit using tilde, so we thought it important to clarify the meaning now. We are going to run a reset command that is referencing the commit that is the parent of the current commit. As discussed, we could have used 6436E8 or head tilde 1. When resetting, you specify the target, essentially what is the version you want to reset to. But what will this do to our commit graph? It simply moves the label back to the previous commit. And you are probably saying right now, okay, but what happens to my files? And what happens to my commit? We are going to look at what happens to the files next. But in respect to our last commit, the answer is nothing. Our commit remains there, unchanged, only the branch moves back. The fact that it remains there shows us that we could potentially get a hold of it if we needed it. But as of the reset, we have no more direct reference to it except for its hash. We have no more branch pointing to it. As for our files, the answer to the question what happens to them is a bit more nuanced, because it depends on the flags we configure our reset with. In case of a soft reset, from the point of view of our repository, the versions of the files it holds will be the one that is at the commit our head points to right now. Let's call this the old version. Still, the staging area and the working directory will hold the most recent version of the files unchanged. It's like we already implemented the changes and have added them to the staging area with git add. In our example, we have undone all changes to the readme file. In the case of a hard reset, the situation is a bit different. A hard reset will do the same thing a soft reset does, but it will reset the staging area and the working directory as well. It looks as if we deleted the new versions of the files. We returned completely to the old version. This reset is good if we want to utterly drop all changes since the commit we reset to. But there is also another way of resetting, the default one. Mixed reset is the perfect middle ground between soft and hard. Can you guess what happens to our files? Our repository, as in the previous cases, will have the old version of the files. Our staging area will have nothing added to it. Please remember this is a simplification. And our working directory will have all the new stuff. This means that we could potentially add and commit the changes again if we wanted to. Knowing all of this, what should we consider when we want to reset? First of all, ask yourself a question. Did I or didn't I already push the commits I want to reset? Not the commit you reset to, but the ones which are going to be undone. If those commits have not been pushed, if nobody but you has access to them, then feel free to reset. It's safe and painless. You can use any of the types of reset, but be aware that a hard reset will delete your changes, and it's a pain to get them back. A thing which in some cases might even become impossible. If you pushed, or if someone else already has any of the commits that are going to be undone, do not reset, or be aware that it will be a pain to sync up all the repos. Be aware that this can potentially affect branches which had as a starting point one of these commits, even if you are the only one working on them. Reconciling the changes in the branches with the ones in the source branch will also be painful. But you don't have to take my word for it. Let's see why. In this example, our current commit is already pushed to origin. It's our commit. We are the ones who created it and then pushed it. But oh no, we pushed a horrible bug that's going to make it to production. We'll lose our job. No one's gonna love us ever again. But we are Git ninjas. We know what to do. We'll reset the last commit. It will be like it never happened. The world is right again. Our local main label moved to the commit we reset to. But notice how the remote branch remains unchanged. It still points to the undone commit, both on our local copy of the origin main branch and on origin itself. It doesn't even matter what type of reset we've used. Locally, we fix what we wanted to fix and then create a new commit. Because we changed things either in the content of the files or the commit comment or both, the new commit hash is going to be different from the old one. Now we want to push this new commit. Will this work? As long as the two histories are the same, we should be able to. But what is that? The last commit on the two branches has a different hash. This means the commits are different. Whoops! We have this error and it looks familiar. It tells us to pull remote changes. Git does not know what happened. To it, the remote repo is in the same state as if one of our colleagues had pushed their changes. So, push did not work. The error says there are changes on origin we might want to pull. So, let's try that. Will this create a merge commit? We do have a similar situation like we had with our two branches in our last episode. The answer is complicated. We could have a merge, but that would not be okay. Merging the commit on origin back into our tree would potentially bring our undone changes back. This is not what we want. So if we don't want those changes, can we override the changes on origin? We are happy that the new version is the final and correct one. We are going to use our amazing Git master knowledge and use a force push to override the remote tree. This first deletes the remote tree and then pushes the local one in its stead. The push command with the force flag will essentially override the whole remote history. Problem solved. Or is it? Everybody who had the old state will now scowl disapprovingly at you. Forced pushing is a very bad idea when we collaborate. If our colleagues had the old history, they will have conflicts or will potentially reintroduce the old versions into the codebase. Or, if they don't figure out what happened, they will delete their local branch and check it out from the remote again, just like I did when I was first starting out with Git. In conclusion, only force a push if you are really confident you know what you are doing, and that there definitely is no better solution. With such small issues like bugs in the code, there always is a better solution. Let's just revert the last commit. Revert might sound similar, but it isn't. It's non-destructive. It keeps our old commit intact. Don't be ashamed. We all do mistakes. Leaving a commit with a mistake in it is not a catastrophe. We work to create beautiful applications, not beautiful Git histories. Reverting will create a new commit, the red one. It holds the inverse of all the changes that happened in the commit we reverted. In this representation, I use the weird notation of the hash. Note that actually a normal hash is generated for this commit. I only wanted to highlight that the red commit is an inverse or a negation of the commit with a hash of 88F832. Having this extra commit and otherwise the same history means we are going to be able to push, and even if we had to pull any new changes by our colleagues, it still would not be a problem. Reverting is a much better solution in this case if the commit we want to change was already pushed. It does not destroy the history we had, and it won't interfere with colleagues who might have pulled whatever was online. Revert also has the advantage of letting you almost surgically undo one commit regardless of how far down in the tree it is. Reset would reset the whole tree starting with the commit you actually wanted to undo, messing up the whole history from that point onward. You might be asking, okay, but what if I actually pushed sensitive content like an API key? Well, if it's only in the last commit, tell everyone to hold off from doing anything with git, reset, and force push. If it's further down in the tree, you can still remove any trace of this sensitive information, but be aware that it will change the whole commit tree. The operation is not a reset in this case. If you need to know how to do this, look up the git filter branch command and how to use it together with a git rm. In this last case, you will also have to force push, so tell everyone to hold off for a bit. This is it for our second episode. Thank you for watching. This is Paul, and I hope to see you next week when we'll discuss rebasing. Don't forget to like and subscribe.